Okay, so we will be looking at last year's 2023 CAPE Integrated Paper 2 Math exam. Let's get straight into it. So we'll begin with question 1. It's a complex number question. So simplify the complex number 6 minus 7i over 1 minus 2i. So we begin by multiply numerator and denominator by the conjugate of the denominator. Just change the sign in the middle there. So the conjugate of 1 minus 2i is 1 plus 2i. So we multiply both numerator and denominator by 1 plus 2i to keep it equivalent. Okay, so let's expand in the numerator. So 6 times 1, that's 6. 6 times 2i, that's positive 12i. Negative 7i times 1, that's negative 7i. And negative 7i times 2i, that's negative 14i times I is I squared. So negative 14i squared. In the denominator, same expansion. So 1, take the first term in the first bracket. So 1 times 1 in the second bracket, and 1 times 2i also in the second bracket. And then we'll do the negative 2i and distribute into the second bracket. So just as in the numerator. So negative 2i times 1, that's negative 2i. And negative 2i times positive 2i, that's minus 4i squared. So recall that I squared is equal to negative 1. Since I is root negative 1, I squared is negative 1. So we can substitute those. So we have 6. And if you group like terms, 12i, take away 7i. So that's 12, take away 7. 5, so that's positive 5i. And this is negative 14 times I squared, which is positive 14, because I squared is negative 1. So negative 14 times I squared is negative 14 times negative 1. Since the value of I squared is negative 1, and we know negative times negative would have a positive result, so that's positive 14. In the denominator, we have positive 1. 2i minus 2i leaves us with nothing, 0. And here we have minus 4 times I squared, and again I squared is negative 1. So minus 4 times I squared, that's minus 4 times minus 1, and that gives us positive 4. So continuing, so we end up grouping like terms. We end up with 6 plus 14, the real numbers, that's 20, plus 5i, divide by 5. So dividing both terms in the numerator by 5. So 20 divided by 5, that's 4. And 5i divided by 5, that's 1. So solution 4 plus I. Let's move on to the next question. So represent the complex number from your solution in A part 1 on the grid below. The label is IM. We can see this. That's imaginary component, and R real component. So remember the complex number was 4 plus I. So just think of it as 4 plus 1i. So we plot the point 4, 1. So plot the point 4. So 4 on the real axis, and up 1 on the imaginary axis. And we use a ruler and a pencil and draw a straight line. Should be a straight line. I'm using freehand here, but of course in the exam you should use a straight line. Use a ruler, and of course you put the arrow. Alright, and this is a complex number. This is the Argand diagram representing the complex number 4 plus I. So plot a point at 4, 1, connect from the origin 0, 0 to the point 4, 1. You put an arrow on it, and that's the representation. Part B, given that f of x equals negative 7x squared minus 5, and g of x is 2x minus 1, solve fg of x equal minus 68. So we are told that fg of x is equal to minus 68. So let's find fg of x. So fg of x, so f and g of x is, what's g of x? 2x minus 1. So f of 2x minus 1, replacing g of x with 2x minus 1. F of 2x minus 1 is negative 68. So this means we're going to substitute 2x minus 1 in the function f. In other words, we're going to replace x with whatever that we have in the bracket here. Alright, so negative 7 and x squared, replacing the x with the bracket. So x squared becomes 2x minus 1 squared. All we did there is replace the x with the bracket. And then remember the minus 5 equal negative 68. So in solving this, we could get rid of negative 5 but by adding 5 to both sides. So we're left with minus 7, 2x minus 1, all square, and negative 68 plus 5. That's negative 63. And then to get rid of the negative 7, we can divide both sides by negative 7. Divide both sides by negative 7. We end up with negative 70 itself. So we end up with 2x minus 1 all square, and negative 63 divided by negative 7, that's positive 9. So get rid of the square now. Another thing we could do is take the square root of both sides. So we can take the square root of both sides. So we can root both sides. Alright, root both sides. So we end up with 2x minus 1 equal to plus or minus 3. So remember, if we say that, for example, if I say to you x squared is equal to 9, take the square root, x is equal to positive 3 or negative 3, simply because 3 squared give you 9, and if you square negative 3, you also get 9. Alright, so both the positive and the negative, you square either, you'll get 9. So the same idea here. We take the square root of both sides, we have to put positive or negative 3. So 2x is equal to plus or minus 3. Bring that over, or you add 1 to both sides, we get positive 1. Alright, so which means that 2x is equal to, divide both sides by 2. So divide both sides by 2. X, that cancel that, so x will be equal to plus or minus 3 plus 1 over 2, which means that x, so I can separate them now. All right, so which means that x is equal to positive 3 plus 1 over 2, and that would be equal to 4 divided by 2, which is 2. Or would use a negative also, x is equal to negative 3 plus 1 over 2. So plus or minus 3 plus 1 over 2. So positive 3 and 1 divided by 2, or negative 3 and 1 divided by 2. Negative 3 and 1, that's what? Negative 2. And negative 2 divided by 2, that's negative 1. So the solutions are x equal negative 1. Next problem, we are told that the absolute value of 2x minus 3 is less than or equal to 9. So any value between 9, a number line there, put negative 9. Alright. Any value between these numbers will be less than 9. So if you take 8, absolute value of 8 is less than 9. If you take negative 8, the absolute value of negative 8 is positive 8, which is less than 9. Alright, so this is saying that whatever we have in the bracket here, 2x minus 3, it has to be less than or equal to positive 9, or it has to be greater than or equal to negative 9. Alright, so the absolute value, the bracket here, has to fall in this category. Less than 9, greater than negative 9. So these, so we can solve these. So we can add 3 to both sides here, add 3 to both sides, or it's a group the negative 3. It become 12 on the right hand side, and we have 2x on the left hand side. Divide both sides by 2. X is less than or equal to 6. Over here, again, same. Add positive 3 to both sides. So we end up with 2x is greater than or equal to negative 9 plus 3, that's negative 6. Divide both sides by 2. So x is greater than or equal to negative 6 divided by 2. That's negative 3. Let's move on. Part D. Show that x minus 3 is a factor of the function, and we're given a function there. So if it's a function, if it's a factor, then f of 3 should be equal to 0. So let's find f of 3. So f of 3, we find f of 3 by simply substituting 3 for the x in the function there. So 2x cubed, 3 to the power of 3 minus 9, replacing x with 3, so 3 squared, 10x, that's 10 times 3, minus 3, so let's calculate this now. So 3 cubed, that's 27, 27 times 2, that's 54. Remember the order of operations, we do the powers first, alright, indices first. So 3 squared 9, 9 times negative 9, that's negative 81, 10 times 3, that's 30, take away 3. So if we add these, alright, if we add the positive numbers, that's 54 and 30, that's 84, minus 81 minus 3, and then keep a sign, that's negative 84, equals 0. So f of 3 equal to 0, therefore x minus 3 is a factor, based on the factor theorem. Hence, solve f of x equals 0. So we know one factor, that means we can divide to get the other factor. Alright, so to get the other factor, we'll divide. And I'll be doing, you can do long division or synthetic. Let me do synthetic division. So the function, to do synthetic division. So I'll form something looking like a L there. And the inside of the L, you solve x minus 3 equals 0. You end up with x equal to 3. Or just change the sign, positive, negative 3, so we change it to positive 3. So if it was x plus 3, then we would have put negative 3 outside there. In the L, we put the coefficients of the function, and there are 2, we have negative 9, we have positive 10, and we have negative 3. So we bring down the first value, there is 2, and so 3 times 2, that's 6. Add these two numbers, negative 9 plus 6, that's negative 3, and multiply. So 3 times negative 3, that's negative 9. 10 minus 9, that's 1. So 3 times 1, that's positive 3. And negative 3 plus 3, that's 0, which is the remainder, which we expect to get since x minus 3 is a factor, the remainder, of course, will be 0. Alright, so what we end up with below here represents the quadratic of the quadratic coefficients. Alright, so the other factor would be 2x squared minus 3x plus 1, so that's the other factor. And then we can equate this factor to 0. Let's equate this factor to 0 and solve. So we equate this factor to 0. So we can factorize, and it should be an easy factorization. So we have 2x, we have x, minus 1, minus 1. And these would have to be the end numbers, since you can get positive 1 by multiplying the 1 times 1 or negative 1 times negative 1. And remember that the first factor was x minus 3. We also equate that to 0. So we solve that, add 3 to both sides, we get x equal to positive 3. And these other factors, we can equate each of them to 0. So we can equate 2x minus 1 to 0, or we can equate x minus 1 to 0. So those are all the factors. Add 1 to both sides here, we get x equal to 1. So that's a solution, x equal 3. A solution, x equal 1. And the other solution, we can add 1 to both sides, we get 2x equal to 1. And divide both sides by 2, we get x equal to half. So the solutions are x equal to a half, x equal to 1, and x equal to positive 3. So question 1 part E, the coordinates of the midpoint of the line segment PQ is minus 7 minus 2. So the midpoint is minus 7 minus 2. Coordinates of P are 6, 8. So determine the coordinates of Q. Let me call the coordinates of Q x, y. X for the x component and y for the y component. Alright, so think about midpoint. How we find midpoint now? So now I'm going to find the two midpoint by adding two x values and dividing by 2, and adding the two y values and dividing by 2. So the midpoint of P and Q of PQ is this. So if we add the x and y coordinates, so here's the x coordinate for P. The x coordinate for P is 6. So 6 plus the x coordinate for Q, I'm calling that x. So 6 plus x and divide by 2, I'm supposed to get a midpoint, which is negative 7. And if I add, and then for the y now, the y coordinate for the P is 8. Put it over here. The y coordinate for the P is 8. And the y coordinate for the Q, I'm calling it y. And if I average those, divide by 2, I should get the midpoint, which is negative 2. So I can solve, I can just cross multiply. 1 times 6 plus x, that's 6 plus x. 2 times minus 7, that's minus 14. If I group all the constants on the right hand side, that's minus 14, minus 6. So the x is negative 20. And here, do the same cross multiply. Y plus 8, cross multiply 2 times that, that's minus 4. So group y equal to minus 4, group over here, that's minus 4 minus 8. So y is minus 12. So the coordinates of Q would be minus 20 for the x coordinate and minus 12 for the y coordinate. And you can just check your answer and notice the midpoint is minus 7, minus 2. So here's P, 6, 8. Q is negative 20, negative 12. When I add the two x coordinate, 6 and negative 20, that's negative 14, divided by 2, negative 7. Add the two y coordinates, 8 and minus 12, that's negative 4, divided by 2, that's negative 2. So negative 20, negative 12 checks out for the coordinates of Q. We are now at question 2. Let me just write the equation properly. So it's 5 to the power of minus, in the bracket we have 5x plus 8 equal to 25 to the power of 2x plus 5. So the exponential equation, and the aim here is to get both sides to have the same base. Alright, so the smaller base is base 5, so I'm going to rewrite the right hand side as a base 5. So remember 25 can be written as 5 square. So this 25, I'm going to rewrite it as 5 square. And this power here is 2x plus 5. Over here, I have 5. And if I just distribute negative to each term in the bracket, it's like I'm multiplying the bracket by negative 1, each term by negative 1. So I end up with negative 5x, negative 8. Good? So what we have is 5 to the power of minus 5x minus 8 equal to 5, and then we can distribute the 2 to these terms here. So 2 times 2x, that's 4x, and 2 times 5, that's 10. So both sides have the same base, so we can equate the powers. So therefore we can safely say that's minus 5x minus 8 is equal to 4x plus 10. So since the X's are the same, we can just equate the powers, alright? So, what we can do now is group like terms. Let me just group the x's on the left hand side. So, on the left I have minus 5x. If I group the 4x on the left hand side, I'll have negative 4x. And on the right, carry forward the 10. I group this negative 8 on the right hand side, it's now plus 8. So minus 5 minus 4, I don't keep the sign. That's minus 9x. 10 and 8, that's 18. To solve for x, I'll divide both sides by 9. So 9 into itself, that's x. And 18 divided by negative 9, that's negative 2. So our solution there is negative 2. Part B of question 2. So here we have an equation to solve. So we can use the rule of log. So we're going to group all the logs on one side of the equation. So I'll end up with 4 log x minus 2 base 9. Group this over here. So I have minus log 3 base 9 equal to positive 5. Alright, so I just group all the logs on one side. Now there's a line logarithm that says whatever the coefficient is, this coefficient, this 4 I can make it the power here. So if I can rewrite like this, log x minus 2 to the power of 4 base 9. And that's one of the laws of logarithm. Alright, minus log 3 base 9 equal to 5. Another law of logarithm that says log A minus log B, log A minus log B is equal to 1 log, and I can combine these logs by putting A over B. Alright, so I can apply the same principle here. Once I'm subtracting, I can group both terms by dividing. So log, think of this as A, think of this as B. So I put A over B. So I put x minus 2 to the power of 4 over 3. As long as both of them have the same base, in this case base 9, equal to 5. Okay, so what else can we do now? Another law of logarithm. There's another law in logarithm that says, so the law says if I log a value, say if I log A to the base B equal to a power, then it means that A, whatever is in the bracket here, A is equal to the base raised to the power here on the right hand side. So adapting that same principle here, so A will be whatever we have here, alright? So x minus 2 to the power of 4 over 3 is equal to the base raised to the power over the right hand side. So it's equal to 9 to the power of 5. And of course, what we can do is just simply cross multiply, put this over 1, and if I cross multiply, I'll end up with x minus 2 to the power of 4 is equal to 3 times 9 to the power of 5. Continuing, let me continue over here. Let's complete the problem over here in this little box here. So I guess we could use our calculator and work out the right hand side. One thing we could say is say x minus 2 to the power of 4 is equal to 9 9 is the same thing as 3 square. So this is 3 square to the power of 5. Let's look at everything base 3. 3 square to the power of 5. That's since 9 is 3 square. So I rewrite 9 as 3 square. So I'm end up with x minus 2 to the power of 4 equal to 3 times 3 to the power of 10. 5 times 2, 10. Alright, and it's 3 times 3 to the 10, that's 3 to the 11. So x minus 2 to the power of 4 is equal to 3 to the power of 11. And then we can, to get rid of this fourth power, because we're solving for x, we can raise both sides to the power of a quarter. If I raise both sides to the power of a quarter, so I multiply the powers by a quarter, so a quarter times 4, a quarter times 11. So I end up with x minus 2, a quarter times 1 is 1. So just x minus 2 to the power 1, which is x minus 2. And here, a quarter times 11, that's 3 to the power of 11 over 4. And then if I add 2 to both sides, or just group the negative 2 over there, x is equal to 3 to the power of 11 over 4 plus 2. Or you could just use a calculator and work out the value of this. I guess you'll get some decimals of the sort. Let's keep it moving. Sketch the graph of y equal e to the x and its inverse. So the graph of e to the x, when x is, so when y equal e to x, so you want to show the graph for the axis, y equal e to the x. When x is 0, e to the 0, when x is 0, so e to the 0 is equal to 1, right? So when x is 0, y is equal to 1. So the cut the y-axis at 1 is a graph that we are expected to know. So the graph would look something like this, curves up, and then this graph, it never ever touches the x-axis. And the inverse of y equal e to the x, we should know, is a graph log x and log x. And by the way, one thing about reflection, about a graph and its inverse, all right? The inverse of any graph is basically a reflection in the line y equal x. Let me draw the line y equal x. Go through 1, 1, 2, 2, and of course, you have a straight line, so you draw the graph y equal x. So the graph y equal x will look like. So any graph is always, the inverse graph is always a reflection in line y equal x. So log x, so when log x, the graph of log x, when x is 1, y is 0. So y log x pass through, so the graph of log x will look like that. Alright, so they are images of each other. Alright, so this is a graph of y equal to e to the x, and its inverse is log x. So these are the two graphs. Notice they are a reflection of each other in the line y equal x. So Cramer's rule is all about the matrix method. So I'm going to use the matrix method to solve this system of equations. So the first thing we want to do is form 4 matrices. We're going to form 4 matrices and find the determinant of each of them. So let's call the first matrix A, and A will be just the coefficients of all the terms on the left hand side. So that would be, so A, let's find the determinant of A. So that will be 5 minus 3 and 5 again. B, sorry, the second row, minus 1x, 1y, 1z. And then the final row is 2 minus 3, minus 3. Alright? So let's find the determinant of A. So the determinant of A, so we're going to take, let's use the top row. So we take the top row, so 5. So it's the top row times its cofactor. And to get the cofactor of 5, you simply draw a line through the 5, through the row that it's in, through the column that it's in, and you're left with 1, 1, negative 3, negative 3. And then change the sign of the middle term, negative 3, so it will become plus 3. And to get the cofactor of this term, minus 3 here, well, it's now plus 3 since we're changing the sign. You draw a pencil through the column it's in, and the row, and the pencil, and the mark through the row it's in. So you draw a row through that, and whatever you're left with, that's the cofactor. Alright, so we're using the cofactor method, so you're left with minus 1, 1, 2, minus 3. And for the other one, positive 5, so 5. And the cofactor of 5, again, you line through the row that the term is in, line through the column it's in. And whatever you're left with is your cofactor. Alright, which is minus 1, 1, 2, negative 3. So the top first number times its cofactor, the second, but you always change the sign to the second one, times its cofactor, and the 5 through its cofactor. Alright, so we end up with now, let's calculate. So we end up with now that's equal to 5. And we cross multiply and subtract. So minus 3 times 1, that's minus 3. Subtract minus 3 times 1. So minus 3 times, so subtract minus 3 times 1. It will become positive 3. Because that's the double negative, alright? Then the positive 3, right? So cross multiply and subtract. So that times that, that's positive 3. Take away 2 times 1. Plus 5. Cross multiply and subtract. We end up with that times that, that's positive 3. Take away 2 again. Alright, so let's work this out. So we end up with, this becomes 0, so everything will be 0, right? Negative 3 plus 3 is 0. 3 take away 2 is 1. Times the 3 outside, that's positive 3. And then this bracket is 1. So 5 times 1, that's 5. So the determinant of A is equal to 8. So we need to form 3 more matrices. Let's find A subscript X. Now, how do I get the matrix A subscript X? So all we'll be doing is again with the same process, but the first column in A, we're going to replace the first column in A with whatever is on the right hand side. Notice the first column represents the X coefficients, 5, negative 1x, positive 2. So we're replacing the first column with the values on the right hand side, and everything else will remain the same. Alright, so AX will be negative 34, 4, and negative 13. So negative 34, 4, and negative 13. So negative 34, 4, and negative 13. Alright, the other columns will be the exact same. Minus 3, 1, minus 3. Let's widen this. And the final column, will be 5, same as before, same as in A. Alright? So to get from A to AX, we simply replace the first column, that has the X coefficients, with the values on the right hand side. And then we'll find the determinant of AX. Let's find the determinant of AX now, same process. Alright, so the first value, that's negative 34, times the cofactor. And the cofactor will be these, right? If you cross out the row, cross out the column the 34 is in, these are what you're left with, right? So you cross multiply and subtract. I'll move a little faster now. Cross multiply and subtract. So 1 times negative 3, that's negative 3. Take away negative 3 times 1. So it's take away negative 3. Same becomes plus 3, right? A double negative. And then we change the sign for the middle term. So that's now positive 3. And the cofactor of that, cross out the row it's in, cross out the column it's in. Cross multiply and subtract. So that times that, negative 4 times negative 3, that's negative 12. And then minus negative 13 times 1. So a double negative give you a plus. So it's just 13 times 1, 13. And then 5. So it's now positive 5 outside. And then the cofactor of the 5 will be these terms. Cross multiply and subtract. So that times that, that's negative 12. Take away negative 13 times 1. So take away negative 13, a double negative, we end up with plus 13. So just to simplify this calculation, we end up with what now? This is 0, because negative 3 plus 3 is 0. Negative 12 plus 13 is 1. So the bracket is 1. So 3 times 1, 3. And here, the bracket is, what's the bracket? 1, the bracket is also 1. Negative 12 plus 13, that's 1. So 5 times that, that's 5. So AX is equal to 3 and 5. AX is equal to 8. So let me just make a record of it here. The determinant of the matrix AX is equal to 8. So we need 2 more matrices. Alright, AY and AZ. Now if you remember how we got the matrix A was simply using the coefficients of all the terms on the left hand side. Alright, and to get AX, we replace the first column, which represent the X coefficients, with the values on the right hand side. And then to get AY, we replace the second column. And notice the second column represents the value, the Y coefficients. Alright, so notice for AY, we put back the 5, the negative 1, the 2. We put back the 5, the 1, and the negative 3 at the end there, the third column. And then the middle column, which are the Y values, the Y coefficients, replace them with the values on the right hand side. That's minus 34, 4, and minus 13. Let's use the cofactor method now to find the determinant of AY. So the determinant of AY, we take the 5 and multiply it by a cofactor. And the cofactor of the 5, to get the cofactor of the 5, we cross out the row it's in, cross out the column it's in. That's what we're left with. These 4 values we cross multiply and subtract, alright? So 4 times minus 3, that's minus 12. Take away negative 13 times 1. So a double negative, take away negative 13, that becomes plus 13. Alright, if middle value there, we change the sign. So it's positive 34 now. And if it was positive 34, it would have become now negative 34. So whatever value is there in the center there, you change the sign when we're using the cofactor method. Alright, so we want the cofactor now for this 34. So to get the cofactor for the 34, we simply cross out the row the 34 is in, and cross out the column the 34 is in. And these 4 values that we are left with, we cross multiply and subtract. So cross multiply, negative 1 times negative 3, that's positive 3. Take away 2 times 1, that's 2. Good? And then the final, in the top row there, 5. And to find the cofactor of 5, we cross out the row it's in and the column it's in. You cross multiply and subtract these values. So that times that, that's positive 13. And that times that, 2 times 4, that's 8. Let's simplify this. So we end up with the bracket, negative 12 plus 13, that's 1. Multiply that by 5, you get 5. The other bracket, 3 times 3 minus 2, that's 1. Multiply 1 by 34, you get 34. And then the final bracket here, 13 take away 8. That's 13 take away 8. 5. So this bracket will come to 5. So it's 5 times 5, that's 25. So the 5 and the 25 is what? 5 and 25 is 30. 30 and 34, that's 64. So the determinant of AY is 64. So using Cramer's method, we have one more matrix to find, and that's AZ. Let's find AZ. Let's find AZ quickly. Alright, to get the matrix A subscript Z, again, we simply replace the final column now with the values on the right hand side. So notice we put back everything we have in A. So 5, minus 1, 2, minus 3, 1, negative 3. And we're replacing now the Z coefficients. Notice, look at the Z coefficients. 5Z, 1Z, negative 3Z. Replace these with the values on the right hand side. So minus 34, positive 4, and negative 13. And let's find the coefficient, the determinant of the matrix AZ. So same cofactor method, go a little bit faster. So the 5 and the cofactor of 5 would be these numbers, right? Cross multiply and subtract, so that's negative 13. Take away negative 3 times 4. So it's negative 13, take away negative 12. And a double negative give me plus 12 in the bracket here. Change the sign of the middle number, so that's positive 3. And the cofactor of the 3 will be, just cross what the row is in and the column is in. So the cofactor is cross multiply that times that. Negative 1 times negative 13, that's positive 13. Minus 2 times 4, that's 8. And the final value there in the top row, whatever is there, you put that back. And the cofactor for the 34, cross what the row is in, cross the column is in. And these 4 numbers, cross multiply and subtract. Negative 1 times negative 3, that's positive 3. Take away 2 ones 2. So to simplify this, we'll end up with now. So the bracket here, negative 13 and 12, that's negative 1. Times the 5 outside, that's negative 5. 13 take away 8, that's 5. Times the 3 outside, so that's 15. And 3 take away 2, that's 1. Times negative 34, so it's negative 34 times 1, that's negative 34. So we end up with now, so negative 15 and 5, that's 10. 10 take away 34, that's negative 24. So the determinant of A Z is negative 24. So in Cramer's method, we simply find the determinant of, write down the 4 matrices, find the determinant of each. Let's get the solutions now. So the formula for the solution should be straightforward to be able to recall. The x value is equal to A subscript x, determinant of ax divided by the determinant of A. And if you notice that ax is 8 and the determinant of A is also 8, so the x is equal to 1. Let's do the y value. Very easy. All of them have the same denominator. So for the y, denominator is the determinant of A. The numerator is the determinant of A subscript y. And same denominator of 8, A. And then ay, that's 64. 64 divided by 8, that's 8. And then the value of z, as you can guess, is A in the denominator. So all of them, notice all of them have the same denominator. Determinant of A, that's the original matrix. And in the numerator is A subscript Z. So is 8 in the denominator. A subscript Z is there, negative 24. So negative 24 divided by 8, that's negative 3. So the solution, x equal 1, y equal 8, z equal negative 3. And you can do a quick check to your solution. So let me just check it with the second equation. So we are saying x is 1, so negative x will be negative 1. Plus y is 8. Plus z is negative 3, right? So negative 3. Z is negative 3. So when you add all of these values, you should end up with positive 4, according to the second equation, right? So 8, negative 1 plus 8, that's 7, 7 take away 3, 4. And if you try with all the other 2 equations, it should work out to give you whatever is on the right hand side. So that's part D. Alright, so part E, solve the equation 5 tan x, so 5 tan, and we have in the bracket x plus 7 equal to 10. So naturally you can divide both sides by 5, x plus 7, divide both sides by 5. So we have 2 on the right hand side, 5 into that, and we have tan x plus 7. Which means that x plus 7 is equal to tan inverse 2. x plus 7 is equal to tan inverse 2, which means that x plus 7, I'm just bring over the, come over here. So x plus 7 is equal to, now tan inverse 2, what's tan inverse 2? Tan inverse 2 is, so if you think about where the tan is positive in where's tan positive? Tan is positive in the first quadrant. So remember the thing, all science teachers are crazy. So tan is, so all of them positive in the first quadrant. And it was 63.4. I think that's what the calculator will give you. Just use one decimal, please. 63.4 degrees. And if you want the other angle, tan is also positive in the third quadrant. So this is 0. Over here is 180. So to get to the third quadrant, you can add 63.4 to 180. And you'll get 243.4 degrees. So these are two quadrants in which tan is positive. So 63.4, that's a primary angle. And to get the other angle, you add 63.4 to 180. You'll end up in the third quadrant where tan is positive. And of course, we can subtract 7 from both sides. So we can subtract, since x plus 7 equal to the solution, we can subtract 7 from both of them. So x equal to 63.4 minus 7. And that will give me 56.4 degrees. And you can also subtract 7 from the 243.4. You'll end up with 236.4 degrees. But the question says the angle x should be negative. Notice this, x should be less than 0 and greater than negative 2 pi. Negative 2 pi is equivalent of negative 360 degrees. Since pi radians is equal to 180 degrees, right? So 2 pi would be 360. So negative 2 pi, that's negative 360. So you want the negative angles. To get the negative angles, you simply subtract a revolution from them. So from both of these values, you subtract 360. So one solution will be 56 minus 4, take away 360. And that would give you a negative value, which is negative 303.6 degrees. And to get the other angle, you subtract 360, one complete revolution from the angle there. So 236.4 take away 360, negative 123. Since I want negative values for x, so these would be our solution. Alright, so that's our solution. And why I was just remind you why we add the 360. If you think about it, if you have an angle, let's say you have an angle. Let's say you have an angle 0 degrees here, right? And if you go around 360 to the left, you end up right back at 0 degrees. Or if you go about from the other direction, you still end up at 360 degrees. So 56.4, a complete turn. A complete turn, you can get a complete turn by either adding or subtracting 360. But you want the angles to be negative, and that's why we subtract. So we can have negative solutions, since we are told that the angle should be negative. Alright, let's move on to part F. This should be the final part. Part F. A journal bought a car at the beginning of 2016. The value of the car depreciates according to the following model. And the model is V. Value is 70,000 times 6 over 7 to the power of Y, where V represents the value of the car and Y represents years after the car was purchased. Calculate the value lost on the car at the end of 2019. Alright, so the value, the new value, so 70,000, and it was bought in 2016, so it's now 2019, so the amount of years will be 3 years, alright? So 70,000 times 6 over 7 to the power of 3, or y is 3. So let's calculate this. So v is 70,000, and then 6 over 7 to the power of 3. You're basically multiplying the fraction by itself 3 times, right? 6 over 7 times 6 over 7 times 6 over 7. So you multiply 6 by itself 3 times. 6 times 6 times 6. 6 times 6 times 6, 216. And then 7 times itself 3 times. 7 times 7 times 7. That's 343. Right? So the value after 3 years, if you calculate it, so 70,000 times 216 divided by 343. So the value after 3 years will be $44,000. $44,081.63. Oh, the question was to find the value lost. So the original value, so if you think about the original value, year 0, if you think about the original value, year 0, the original value will be 70,000 times 6 over 7 to the power of 0. That's the moment the car was bought. And 6 over 7 to the power of 0, whatever a non-zero number to the power of 0 is 1. So it will be 70,000 times 1. So the original value of the car is 70,000. And after 3 years, so in 2016, 70,000. After 3 years, that's up to 2019, this is a new value. Alright, so the value fell from 70,000 to 44,000. So the value lost, this is what they want us to answer, the value lost. Alright, so the value lost will be 70,000, that's the original value, minus the new value, 44,081.63. Would be, so the new value would be equal to, well, the new value is 44. So the value lost would have been 25,918.37. So again, the original value, 70,000, because in year 0, when y is 0, the value is 70,000. After 3 years, the value is 44, or 81.63. So in other words, the value, it lost 25,918. Let's move on to question 3. That's a section on statistics.